In this video, we're going to finish out kind of our first set of hypothesis tests. There will be additional videos for regression and ANOVA that will be separate. So in this one, we're going to finish out with chi-square tests. Now remember, chi-square tests are going to be looking at categorical variables, and categorical variables specifically where we have more than two levels. So not able to do proportion tests anymore, we want to consider something with more than two levels. With this, let's consider our award variable. Now with our chi-square test, remember we have two approaches. Our first one is a goodness of fit test. The goodness of fit test, we need to have some assumed underlying distribution or split between the different categories. Now, one of the more simple methods is to assume that all of them are equal, but as we have looked at the award variable, we might not think that that's entirely accurate. That may not be the test that we want to run. Perhaps somebody comes along and tells us, hey, we think that, and I'm going to create a vector here, null proportion, just for us to keep track of. We think that it's actually 15% of students want to win an Academy Award, 40% would like to win a Nobel, or let's make it 35% want to win a Nobel Prize, and the last 50% wish to win an Olympic medal. Remember, these hypothesized values need to sum up to 1. If we have this distribution and we want to test, does this fit the data that we've observed well, we can use the chisq.test function. Now once again, most commonly used method is to pass in this table. So I'm going to pass in student award within this table function. Now if you just run this as is, don't add anything else, it's going to assume that you want everything to be equal. Now it's not really going to specify that very well either if you just run this value. So do be careful and watch what you're working with there. Now another option, let's actually take a look at all of the options that we have. One, do know that there is this correct equals true argument that is the default in R. This is going to do, again, a small sample size correction. If you have a large sample size like we have, it's not going to make much of a difference. It is typically suggested for smaller sample sizes, but do be aware that if you are using this to answer a homework question, your homework may not be expecting that. Now other options, notice this P. This is our assumed distribution. So now that I have this null proportion variable, I can pass that in here, or you could just specify them directly in there. And now if I specify this and pass it in, then it's going to conduct a test, but it's going to do it as though testing against these null values for the proportions. And so we can see this is definitely a little bit different. We still don't see a significant, or we still see a significant result, so we would still reject our null hypothesis and conclude that no, this doesn't fit very well, but this is more accurate to what we were working towards. Now do note that with the chi-square test, we'll test it here, if you just run this, this is the output you get. What you may want to do is save this whole thing as an object, because if you do this, well, I don't get any output here. But there are some additional values that you can extract from this in R that you may be interested in. If you just type the name of this object and hit return, you're going to get that same output. But if you do the $, you can see there are quite a few additional values in here. One of which that may be interesting is this expected value. And so if you run this and ask for it, it's going to tell you, according to your null proportions, these are the numbers we would have expected to see. So if you need expected counts, this is one method that you can use to get those. All right, that is the goodness of fit test. That's for one categorical variable. If I have two categorical variables, I want to do my test of association. And this one, in fact, is probably a little bit easier than the others. We're going to use a table function again, but perhaps this time I'm still interested in award, but I want to know, is there an association between award and smoking status? Now, if we were to just look at this table, we'd see, okay, looks like we see much less for Academy, Nobel, But Olympic only has one more smoker than the Nobel Prize, but it has a lot more non-smokers. So maybe these aren't quite as evenly distributed. In other words, maybe there's an association. This is the chi-square test we can run. And we just need to pass in this two-way table into the chisq.test function and run it. Now once again, you can either just run it directly and get your output, or perhaps you can run this and save the value. I'll make it chi-square 2 so that you can extract information otherwise. Now do note, if you violate our underlying assumption of at least 5 observations, or R uses a requirement of the expected count should be 5 in each cell, R is going to give you this warning. So do be aware of that. It's still going to perform the test, it's still going to run everything, but you need to be aware of this when you make your interpretations. All right, what result did we get? If I pull out my chi-square 2, we'll see we actually get no significant association between the two. But perhaps I'm interested once again in my expected counts. So I can run this, pull out expected, and now we see what the expected counts would be if you want to do all of this by hand separately to double check, or just to see how things match up. All right, there are chi-square tests.